Okay, one of the things that you need to be able to understand for a regression line is what the gradient tells you and what the intercept tells you. So let's say, for example, we've got a scatter graph that looks something like this, and on that you have drawn your regression line, and it looks something like that. And let's say that your axes represent, okay, so let's say your x-axis is temperature. And temperature is measured in degrees C, degrees Celsius, and let's say Y is the number of ice creams sold. So the number of ice creams sold. And so let's say perhaps this is something which has been, an ice cream seller has been collecting data, he's been looking at the temperature each day, and he's been measuring or calculating the number of ice creams that he's sold. And let's say that he has found out that the equation of his regression line is y equals 17.1 plus 0.583x. And the question says, so in other words, our b here, the gradient is 0.583, and a, which is the intercept, is 17.1. And the question says, explain what A and B tell you in the context of the question, or explain the meaning of the values of A and B. So let's have a look at A first. Now A is the intercept. Let's assume that these are both 0. That's the origin. A is the intercept here, 17.1. And what that actually tells you, this is fairly easy to work out, is that when the temperature is 0, or let's say in this case the minimum temperature, well, let's call it freezing point. Basically, it would mean that if the temperature was 0, then the number of ice creams sold would be 17.1. So that's usually fairly easy to interpret. Okay, so the intercept is the number of ice creams sold when the temperature is 0. So you must explain that in context. The gradient, though, is a little bit harder to interpret. So let's have a think about what that actually means. If we look at our line, the gradient is 0.583. Now, what that actually means is if you've got a gradient of 0.583, I draw in a right-angled triangle there. You know that gradient is vertical divided by horizontal, or if you like, rise over tread. Well, let's just imagine that the horizontal distance here is 1, because that just makes life a little bit easier. If that's 1, then this vertical distance will be 0.583. So let's just have a look at what that means. That 1 is actually 1 degree centigrade, and that 0.583 is actually 0.583 ice creams. And what it means is this: for every 1 degree rise in temperature, the ice cream seller can expect to sell an extra 0.583 ice creams. And that word extra is very important. So basically, for each rise of 1 degree C, he expects to sell an extra, you must use the word extra there, an extra 0.583 ice creams. And that's the meaning of the gradient. I find it usually easier to draw a little triangle, put 1 across the bottom, and then whatever your gradient is up the side, and then interpret in the context of the question. Intercept, remember, is usually easy to interpret. Gradient is less easy.